Welcome back, friends. Today we are going to start our new topic, that is modeling principles. As we know that we have started our unit third, and into that we have started the principles that guide practices. In the roof of this heading, we have completed all these points. We have to just move further and take a new point, that is a modeling principle. Next one is a construction principle, and last one is a deployment principles. Okay. So today I'm going to talk about modeling principles. There are 10 principles. According to that, we have to build a software so that we can get our required information or required project as per the customer satisfaction. Okay, so let's get started. Uh, in modeling principles, there are 10 principles through which we can get a perfect models or guidelines so that we can make a great or as per the customer requirement project. In software engineering works, two classes of models can be created: requirement models and design models. Yes, of course. Model is just a skeleton of a project that guides us to development step by step approach. Okay. In modeling, what we have to model, actually we have to model the two things most perfectly, that are requirements getting from the customers, and according to the requirements we have to design. Okay, we are going to get a detail into that also. Requirement models are also called as analysis models, represent customer requirements by depicting the softwares in the three different uh, domains. Okay. As we know that we have already discussed about the requirement gathering in the waterfall models in great detail. Likewise, in this model we have to also take care of requirement models, that are nothing but analysis models. Whatever the requirement gathered from the customer, we have to specify each and every points on a paper or a Excel sheets so that we can get each and everything in your, we can clear all these things, what on which track we have to follow. The next one is the information domain, the functional domain and behavioral domain. Yes, according to the requirements we have to work with a different domains, that are the information, nothing next one is a functional, and the behavioral domain, that are nothing but a task through which we can get the customers requirements on into the software. Design model represent characteristics of the software that helps practitioners to construct it effectively: the architecture, the user interface, and the component level details. Okay, these are the just overview. And now and forth we are moving to the next principle, that are the 10 principles through which we can get a perfect model. First one is the principle, sorry, the primary goal of the software team is to build a software, not a create models. Don't too much focus on creating a model. Okay. uh, because we have actually the primary goal is to create a software according to the customer details or according to the customer requirements. Don't focus too much time, or don't give too much time to create a model. Agility means getting a software to the customers in the fastest possible time. As soon as possible you have to uh, provide the solution to the customer through the agility. Models that makes this happens are worth creating, but models that slow the process down or provide a little new insight should be avoided. Yes, of course, models really helpful to create a project, but it takes a time. And through the agility we have not time. We have to work as soon as possible. We have to provide the solution to the customer as soon as possible and before time. So don't too much waste your time on to create models. Just move on. Next principle is travel light. Okay, don't create more models that you need. As per your requirement, just create a model. Don't focus on the too much creating or in detail or in depth to create a model. Okay. Every model that is created must be kept up to date as changes occur. More importantly, even new models takes time that might otherwise be a spend on constructions, coding, and testing. Therefore, create only those models that make it easier and faster to construct the software. I hope you understood the time is most important while creating software. So don't waste your time to create unnecessary thing. Don't go to other track while creating a software. You have to focus only those models which are actually required for the software. The next principle is strive to produce the simplest model that will describes the problems of the software. As we discussed that each software steps should be a simple and keep it simple and stupid. We have already look after that all these things. That should be a not too much complex or that should be too much easy. It should be a moderated, okay, so then everyone can easily understand. And um, don't waste your time to create a more complex models that won't work for anyone. Don't overbuild, okay, don't overbuild a software. By keeping model simple, the resultant software will also be a simple. The result is a software that is easier to integrate, easier to test, and easier to maintain, to change. In addition, simple models are easier for a member of the software team to understand and critique, resulting it in going in an ongoing for of feedback that optimize the end result. The simple goal of this principle is just use that model which are required, and that model should be a simple so that everyone can understand easily and work with it. Okay. Next is next principle: build model in a way that makes them amenable to change. Amenable is nothing but easy. Okay. Yes, we know that the software is never ever ending process. The new requirements are welcoming, so that we have to be a flexible while doing a software. As well as we, when we create a model, we have to also flexible with that, so that we can adapt each and every point by the time passes, so that can be adapted into the model, so to get enhanced our model. Okay, that should be a flexible, that should be easy to change, to change, or that should be easy to adapt all the other requirements into that. Assume that your model will be changed, but in making its assumptions, don't get sloppy. Yeah, of course. What happened most of the times, each and everyone knows that the requirements are going to be changed in next few days. So the from today they are not working in a proper way. That won't be helpful for each and everyone. We have to focus each and every requirement as a final. Don't be sloopy. Okay, for example, since requirement change, there be a tendency to give the requirement model short shrift. Why? Because we you know that there will be a changes anywhere. So I know that each and everyone know that we are going to change this requirement as per the new requirements will come. So what, yes, but we have to focus whatever you are doing, that should be a qualitative corrective. Okay, that should give a correct performance. The problem with the attitude is to, without a reasonably complete requirement model, you will create a designing model that will be invariable miss important functions and features. Most of the time the features that won't work your project are included into it, or that you just left some pages or some spaces to create a new functions while upcoming requirements. Yes, that won't help you to create a great design. So focus on whatever the requirements you have in your hand today itself, and just work with that with a higher priority, with a qualitative to quality, to maintain the qualities of your software. Mm? Now the next principle is be able to state an explicit purpose for each model that is created. Each and every model have some purpose or goal or aim, or requires some output from that model. That model should be work in a qualitative manner. Every time you create a model, ask yourself why you are doing so. If you can't provide a solid justification for the existence of the model, don't spend time on it. Okay. uh, Most of the time what happen, we are working with the requirements, that requirements are not that much mm, that are not that much work important, or that are not core product or core informations, and you're working with it and spending too much time on that. Please don't do that. If you have to ask, you need to ask your requirements, what are the main goal of this requirements. If it gives a correct or justified answer to you, then spend too much time or whatever you. But if it says no, that are not that much required, or that are not a primary requirements from the customers, please don't waste your time, just move on and work with a primary or a required or core requirements from the customers given. Okay. The next principle is adapt the models you develop to the system at hand. Whatever model you have decided to work with it, just adapt it. Okay. uh, don't just don't waste your time to getting it into. It may be necessary to adapt model notations or rules to the application. For examples, video games applications might require different models techniques than a real-time embedded softwares that controls an automobile engine. Okay. So whatever models you have decided to work with it, just go for it. Okay. The next principle is 7. Try to build yourself models, but don't forget sorry but forget about building up perfect models. While we working with a perfect model, we are just wasting your time. Nothing is perfect, or no one is perfect. As we know that, according to that rule, just create a model. Don't try to make it perfect, because it takes a time, and it should be a workable, or that should be just um, as per your requirement, that is okay. When building a requirements and design models, a software engineer reaches at point of diminishing a return. Okay, that is the efforts required to make a model absolutely complete and internally consistent is not worth the benefit of this property. While you are working with any kind of model, just go with that. Don't waste your time to be make it so much perfect. Otherwise, after that, you will realize that model, whatever you are working with, it is not that much um, perfect for your software. So don't bother with all these things and just move on. Okay. Next principle is don't become a dogmatic about the syntax of the model. If it communicate content successfully, representation is secondary. Dogmatic is nothing but just ambiguity, or don't become a dogmatic. Don't worry about it, about the syntax of the model, whatever the model is work with you. If it communicates content successfully, yes, it is working with you, that model is useful for you while you're working with it, just go for it. Okay. Representation is secondary. Just move on to the primary requirements or primary design or primary content of the project. Don't bother with your presentation. Is presentations we can make it later as per the customer requirement, so don't bother with that. Although everyone on a software team should try to use consistent notations during modeling. Yeah. uh, Consistent notation is nothing but while working with any kind of projects, multiple work colleagues are working with it, and some lost each and everyone should follow some kind of notation that should be a consistent while working with it. The most important characteristics of the model is it to communicate information that enables the next software engineer task. If model does it successfully, the successfully incorrect syntax can be forgiven. Yeah. So of course, if the model is working with in the correct way, don't worry about that. Whatever you have done into that, just as per the required input, just giving that software is, or that model is giving an output, that is okay. Okay. Don't waste your time too much to get into that each and every point. Okay. That should be there. Some points you can neglect it. Mhm. Okay, that can be forgiven. Next principle, the ninth principle: if your instinct tells you a model isn't right, even though it seems okay on paper, you probably have reason to be concerned. Okay, instincts is nothing but your intentions, or whatever you say that your sixth sense is saying that you are working with that model is not that much correct, or you think that on paper it isn't work with on it, probably have reasons to be a concern. So let it go. If you are an experienced software engineer, trust your instinct. That means just if you have a lots of experience regarding developing a software development, just go with your instincts. So instincts is nothing but a sixth sense. Okay. Software work teaches many lessons, some of them on a subconscious level. Communication Sorry, if something tells you that a design model is doomed to fail, even though you can't prove it explicitly, you have reason to spend additional time examine the model or developing a different one. Uh, Simple. The goal of this principle is that just go with your instinct and follow your sixth sense, so that you can get into the models or work with your model, whatever you have decided to work with it. Okay, or spends to a little more time to work whatever you model chosen, to is it worthy to work with it or not. Okay. uh, and the last principle, that is principle 10: get feedback as soon as possible you can. Feedback is the main motivator for the developer as well as the whomever working with that software. Feedback gives you the correct way or the right track on which you are working with your software. Every model should be reviewed by a member of the software team. Intent of this review is to provide feedback that can be used to correct modeling mistakes, change misinterpretations, and add features or functions that were inadvertently omitted. Okay, whatever feedback is given from the customer as well as the end user or stakeholders, that feedbacks gives you the correct track, that you are working on a correct track or not, or you are working with a perfect model or not. If something is going wrong or some lacunas are there, you can easily maintain each and every part uh, as early as possible, so that no one can make mistakes in future. uh, I hope you understood each and every points of these principles of models, working with it. Okay. So any kind of problem is of it, if any point is not understood, please comment section, write comment in comment section, so that I can get back to that problem also. I hope you enjoyed this video. Okay, thank you, take care.